Good afternoon, everyone. So, so last class were unable to complete it because of some technical issue at my side. So that was resolved yesterday afternoon. So I was not able to record the class. So I will just like to continue with the same program which we have stopped there today. And in the next class from tomorrow, we'll start about discussing trees and graphs. So the leftover topic in the data structures. So the first thing now is that day we are discussing about the circular linked list. I hope my screen is visible to you and my voice is audible.
Yes, yes.
Okay, fine. Now this is circular linked list. So just to repeat what the definition of circular linked list, it is a double linked list in which each node consisting of three parts. So we have the information part, we have the next pointer and a previous pointer. The next pointer holds the address of the next node, the previous pointer holds the address of the previous node. So what is the difference between double linked list and double circular linked list here is in double linked list, the previous part of the first node, the previous address, previous pointer of the first node contains null, and the next pointer of the last node contains null. But whereas in case of double circular linked list, so the previous pointer of the first node contains the address of the last node, and the next pointer of the last node contains the address of the first node. So the advantage of this is you can traverse the list in both the direction from any node in forward and backward direction. And another interesting feature here is you can traverse the entire list. Given an address of one node, so you can traverse through the entire list. Okay, so by reaching the last, again you can come to the beginning node and you can complete the entire traversal here. Okay, so just we need to understand now again the implementation of this particular list, how we have implemented, okay, how the pointers are linked. Of course, the same thing we are discussing about scanning the information part. You can try out with an examples where you can have different information parts, and just again I will forget that say I'm giving an assignment to you. Just note down this assignment very clearly that we in double linked list or double circular linked list or in a stack or queue or whatever it is, you are just maintaining a list there. Now after the list, after you have entered the entire list, I want that list I want to make that list as a sorted list. Means there is an unsorted list which is generated. So if you choose an option, then the list should become sorted list there. So you just try out a program, so that I won't be discussing with you. I want you people to write the code for that and submit to me later on. Okay, let me see how many of you all will work on that. You develop an unsorted list using some program, means unsorted list using a function. Then you, by selecting an option, the list should become sorted list. So how you are going to link means how you are going to convert the list as a sorted list, you need to work on. Okay, that's it. Of course, that is your assignment. Now coming back to the program, now I need to develop the same list, the list um, a circular linked list now. So how we are going to implement now? Let me go and check out the program which we have written. So in this program, again the same structure I'm going to take. Okay, a character name and a long integer phone number. Then we have a next and previous self-addressing pointers, so which are supposed to show the address of the next node and the previous node respectively. Then we have a head pointer and a tail pointer, which are storing the addresses of the beginning node and the ending node. Then three prototypes of the functions we have declared here: the insert function, the remove function, and the display function. Then we have uh, the main menu, the main method, main function in which a menu is displayed, where you are going to read the option from the user, whether to insert a node or a delete a node or viewing a node. And then if it is as per the respective option, the respective method is being called. So that we are looking right from our first program. Now in the insertion, see what we have done now is this is all the stuff, this is all the basic linking stuff which we need to understand. Okay. The thing here is to see here a node P is created. A node P is created. Now assume that these all things are not there. Now just I would like to generate the list now. No nodes are existing. So both head and tail are containing null. Now I just want to create a node. So for creating a node, a new node is created, which is pointed by P. So you are entering the information here as usual. You are entering the information as usual. Then what we need to now check here is assume that P next and P previous both contains null. Just I'm writing N there to indicate null. Okay. Null. Now, if it is head is equals to null, when head is null, when it is the first node. When no nodes are existing, then head is null. Then I am saying head and tail are equals to P. Both head and tail, okay, will point to P now. Will point to P. In the sense, so we have both the pointers now pointing to the first node. It should contain the address of the first node. So both should contain the address of the head next is equals to P, head previous is equals to P. So because they're pointing to the same node, so head is head. Just excuse me. Okay. Now both are pointing to the same location. Now head next is equals to P, head previous is equals to PP. So also both are pointing to the same node there. Okay. So both are pointing to the same node. So let us assume that L indicates the address of the last node and F indicates the address of the first node. So I will just use L and F instead of marking them. Okay, so both points to the same. Then this is the last node, this is the first node, so both are pointing to the same address. Then you will go back again, you will call one. So again the name and phone number are generated. So this time P will be pointing to this node. This is our second node now. This is our second node. Okay, then you come here. So because head is not equal to null this time, it comes to the else part. It comes to the else part. And now I'm saying tail next is equals to P. So tail next is equals to P in the sense P is pointing to. So tail next is this one. Tail next is this one. So it is equals to P. Tail next is equals to P. Okay. Then you have P previous is equals to tail. So P previous is this one. This equals to tail. Then so P previous is equals to tail. Okay. Then what is saying? Tail equals to P. So tail equals to P. So now tail is pointing to P here. Tail is pointing to P. Now this should contain the address of the first node. So as I said, yeah. Okay. Yeah. Address of the first node. So let us assume address of the first node is H, the head node. And address of the last node is tail. Okay, T. So head previous is equals to tail, T. And tail next is equals to head. So it has been linked now. Got it. So now it goes to the next time, the third node. So same thing will be repeated. We will just check out for one more node, and we will go on for the other methods we are having. Okay, so assume that again it created a new node. So P will be pointing to this time this one. P will points to this one. Then it will again come back to it will come to the else part. We have tail next is equals to P, and P previous is equals to tail. So tail next is equals to P. We have tail next. This is tail next, which is pointing to P. Then we have P previous, which is pointing to tail. We have P previous, which is pointing to tail. Then we said tail is equals to P. So tail is equals to P. Then we have head previous is equals to tail. So the tail address, and tail next is equals to head. So the head address is stored here. Okay. So head previous is equals to tail, and tail next is equal to head. Like that, we are going to create all the nodes, and then we can continue with adding more nodes here. So assume that the 4 nodes have been created like this. Okay, fine. So this is the list which we have created. Then we can go for the second option, where you are going to have the display. In the display, we are saying, first of all, you are assigning the head to null. If head is equals to null, then no node is existing. Otherwise, P will be pointing to head. And we have a forward display where we should go for you are going to display the name and the phone number there. and p is equals to p, next we'll go for the next node, and p not equal to head. So only this condition has been changed from the double linked list. In double linked list, we have mentioned p not equal to null actually, because the next part of the last node, the next pointer of the last node contains null value, but here the next pointer of the last node will contain head. So until head comes again, so you are going to traverse the entire list and you are going to display. Likewise, if you want to have a backward display, so you are assigning the pointer to tail, then you are displaying the phone number and the name and the phone number, and then you are going backwards by stating p is equals to p previous. So again, the p not equal to tail. So previously in the double linked list, because the previous pointer of the first node will contain null value, so we have the condition there that p not equal to null. But here, because the previous pointer of the first node will contain the tail address, so we are checking whether p is not equal to tail or not. So that's about displaying the content here. Now the removal. So the removal is also same as a double linked list, but only thing here is you have to link up the last, means the last pointer, the next pointer of the last node to the head address, and the previous pointer of the first node to the last address. So that should be carefully done. So now again, assume that I am reading a name here, and which is existing. So if head is not null, no node is existing, you are going to return. So if head is, now first of all, if it is the first node, now assume that I want to remove the first node itself. So if it is removing the first node, what is done? Okay. Now what is done? If p is equals to head, so first of all, I'm pointing p is pointing to head, first thing. Okay. And if head next is equals to head, see this condition we have written here. Why we have written first this condition? If head next is equal to head, when head next contains head address, when it contains the address of the first node, when it contains the address of the first node, and it is the only node which we are having. If it is the only node which we are having, okay, then the head next also contains the head address, right? So now, because we are having more than one node, so this condition fails here. If it is true, means if you are having only one node, then head and tail will become null, and simply you are going to delete the first node by saying 3p, and you are going to return. So because we are not we are having more than one node here, so assume that sorry, it is going to come to the else part. So else part, what we are saying, head is equals to head next. So head is equals to head next. Head is equals to head next means you are moving the head pointer to this node. Okay, then head previous is equals to tail. So here, instead of having this address now, we are saying head previous is equals to tail. So the tail address is stored there. Then we are saying tail next is equals to head. Now the new address. So previously the this first node, which is now been deleted, that address is there. Now again tail next is equals to now head is pointing to SSS, its address is stored there, and now you are saying free p. So when free in the sense in the memory, this particular node is deleted, okay, and then you are going to return. Fine. Now, if suppose you are not, it is not the first node which you are supposed to delete. Assume that it is not the first node you are supposed to delete. Now you are having the list like this, and now you want to delete FFF. You want to delete a node FFF. Then what you are going to do? So it will come here. It will check first of all is whether it is head is null or not. Head is not equal to null. Then it will compare with the first node. The first node also we are not going to delete. So that's the reason why this condition also fails. So when it got failed, now it is coming to this particular piece of code. From here it is going to come. So first P is assigned to head, while P next not equal to tail. So previously we have written here P next not equal to null. So this time we are saying P next not equal to tail, and okay, P next, of course this condition is same. P next is not equal to tail, and strcmp of P next name comma str equals to 0. What is P next name? P next is this one. P next name is SSS. So because P is pointing to the first node, its next is the address of SSS, and what is the content there? SSS comma FFF not equal to 0, true. Then P is equals to P next. So because P is equals to P next, so P will be now pointing to this one. And again, the while loop has not been failed. Again, it will go back. P next not equal to tail is true. Then strcmp of P next name. P next name is FFF, and str also contains FFF. So FFF comma FFF not equal to 0 is false. Because it false, it comes to this path. So now I'm checking whether P next name comma str equal to 0. Is P next name comma str 0? So what is P next name is FFF, and str also contains FFF equals to 0 is true. So when it is true, now this particular piece of code is going to execute. This particular piece of code is going to execute. So we are saying T is equals to P next. So T is equals to P next. So now there is a pointer T which is pointing to this one. Pointing to this one. Okay. Then T next previous. T next previous. So T next is also FFF. Okay, the same content is there. So let me change the content. For example, avoid confusion. Last time someone asked, what if the same content is there in two nodes? So we are just looking for the first node which is consisting of that thing that will be deleted. So assume to avoid confusion now. For example, so what is P next previous? P next previous means this one. Okay, where my mouse pointer is blinking. Now the cursor is blinking. That part should now T next previous should contain T previous. What is T previous containing? T previous containing the address of SSS. Now this should contain, okay, now means this link is removed and the address of this node is stored there. Okay, next is a T previous next. What is T previous? I'm sorry. So just a small mistake is done. Now, T next previous is this one. It contains the address of SSS. Should contain the address of SSS. Where is means T previous. What is T previous containing this one? Okay. T next previous should contain the address of T previous. So what is T previous containing this address? So this, instead of pointing to this one, I'll point to this one. Okay. T next previous. Instead of pointing to this one, now it is pointing to this one. Now T previous next. What is T previous? Contains the address of SSS, and its next is this pointer. Now it should contain the address of T next. T next actually contains the address of GGG. Now this will be now pointing to this one. So like this, the linking is done now. So after doing this, what I am saying here, if T is equals to tail, T is not equal to tail. If it is the last node, I have to make it, bring it to the previous node. So because it is a not node, now I'm saying free T. So free T in the sense I have to remove this particular node. So when I say remove this particular node, see, when I remove it, still the link is being maintained. So that's what I just want to show you, that still the link is being maintained. So still we have the address of the next node here. Means you can traverse through the entire list. So like this, the nodes will be deleted. And if it is the last node also, you can work out on that. The last node will be deleted. So if the no name is given, so simply we'll display that name is not found, and we are going to return. So this is how we are going to delete or remove a node from double circular linked list. Got it? So any doubt for anyone?
No, sir.
No doubt?
No doubt, sir.
Okay, fine. It's fine. Now this is about the linked list. So what else you can do under this particular implementation? What else you can do? You can write lot of other methods also. Okay, under this like for instance what type of operations we have created a list, we have traversed the list. Okay, we have inserted the element in the list, we have deleted an item from a list. Now what you can do here is you can search for an item in a linked list. So you can go for searching whether it is available or not. Okay, you can go for searching, and then after searching, you can say that the element is found or the element is not found. Okay, like that you can go. And merging two or more linked lists can also be done when you are supposed to merge. How you are going to merge, whether the address part of the last node, okay, should point to the head, the first node of the other list. Okay, I hope you understood how we are going to merge, how we are going to join. Okay, the last means to the last node. Like see in the train compartments, already the compartments are there. And if you want to join more compartments, what we are going to do, you are going to bring the other compartments, and you are going to link up to the last compartment. Like that you can do. Okay, so likewise, you can generate a list searching mode. Then you can develop a sorted list. Already existing linked list is there. You can generate a sorted list also. So like say, if you try to practice more and more methods by writing, so your programming skills will surely will improve. So the only thing here is you need to actually work on this. You need to work on this, how you are going to link up, how you are going to do it. These all things you need to do. So I am going to share this PPT also. This is some PPT which I got from the Google. Someone has prepared is Professor K. Adishesha. Okay, so I have taken that PPT and I explained you. Okay, so you can go through this PPT also. So tomorrow's class, then we are going to discuss about the trees, what is the terminology, what are the binary trees we have. Okay, what type of trees we have, we will discuss in the next class. Okay, so before winding up, any doubts regarding this linker list, you can ask me.
No, sir.
No doubts?
No, sir.
No, sir.
Okay, then fine.